Move on to the next speaker. We have Dr. Randall Nichols. Nichols is our speaker. His talk is about small-scale UAS cyber terror implications and cyber navigation threats and Chinese UAS intelligence capabilities and impending invasion of Taiwan. Dr. Randall Nichols, DTM, is a professor of practice in unmanned aircraft system, cybersecurity at Kansas State University, Aerospace and Technology Campus in Salina, Kansas. Nichols serves the Director, GC Aerospace Cyber Operation Program. Nichols is internationally respected with 52 years of experience in leadership roles in cryptography, counterintelligence, counterterrorism, InfoSec, cybersecurity, unmanned aircraft, underwater systems, and sensitive computer applications. Throughout his career, Nichols has published 14 best-selling textbooks. Nichols has provided counsel to United States government and is certified as Federal Subject Matter Expert, SME, in cryptography and computer forensics. His most recent work involves creating master's and certificate graduate level programs for KSU and Utica College. Dr. Randall, it is my distinct honor to invite you for this CARS symposium. Thank you for accepting our invite, and now the floor is yours.
Can you hear me? First of all, let's start off the easy way here.
Yes, we can hear you.
Okay, good. Give me just a minute while I bring in the screen sharing side, if it's all right. And see if I can get this thing working the way it's supposed to, since we've had fun with it in the past.
Yes, we can see your screen. Is it full screen?
So far, it's not reducing. Okay, one more thing here. Nope, that went the wrong way. Pardon me while we get it together here. Great. See this one, but I can't get it up to the level I want it to be. There we go. Now, if we can get out of this. And
very good.
Almost there. And now I want to go from here. Okay, can you tell me whether that's visible or not?
Yes, we can see your books.
All right. For the attendees and also the virtual attendees, thank you, by the way, for the fine introduction. 6 of the 8 of the textbooks that we use out at KSU represent about 7 years of our work, collaborative research, and so on. They're available as ebooks. All you have to do is send me a email. I'll be glad to send you the ebook text links. They're free and they're checked, and there are no APTs associated with them. Or you can send it to Prakash, the chairman. Let's get going because this is a large presentation. So what am I going to talk about? Small unmanned aircraft systems and medium unmanned aircraft systems represent quite a cyber terror problem. So to look at this thing, I got to look at it in terms of a metric. And we've talked in the first 2 presentations about risk. We use the Ryan Nichols qualitative risk assessment. You'll see that there is some similarity to SB 800-30. In fact, we published for 4 of them, but we use countermeasures in our risk assessment. Basically, when we get done, I'm also going to answer one of the questions about impact and vulnerabilities that was asked. Our activity looks at threats and countermeasures. So the first thing I'm going to start off with are dirty bombs. The next thing I'm going to look at are communication, separation, navigation threats, which are primarily SCADA systems that can be attacked by either jamming or spoofing. I'm then going to talk about some very active countermeasures. One of the best ones out there is Eichelberger's collective detection, which is able to detect, mitigate, and recover signals from satellites that have been spoofed or jammed. I then want to go into something that's much more serious. Our real enemy is not the Russians, as you hear on the news all the time, it's the Chinese. There is an impending invasion of Taiwan. I've looked at it for now more than 2 years. And I'm going to show you some of the slides that are open and what potentially can happen. Another intelligence problem, or another cyber problem, if you will, is cutting the submarine sea cables and what the effect will be there. And then lastly, I'd like to give you a look at some of the unmanned aircraft arsenal and also underwater arsenal, and also the intelligence operations underwater that are being built in the South China Seas. So first of all, the risk of success of a terrorist attack against our air defense systems is much worse than we want to admit. And it's because we have commercial capabilities that have improved the accessibility and low cost, and training on these things are very easy. Unfortunately, or fortunately, depending on which case you're looking at, it's quite easy to weaponize. How? Well, we're going to use small and medium drones, and they're capable of carrying all kinds of equipment between 5 and 20 pounds. Some of the bigger ones a little bit more, some of the lesser ones about 5 pounds, but sophisticated imaging equipment, incredible, down to levels that are unbelievable at times. Significant WMDD, which is weapons of mass destruction and disruption, the latter being a case, and payloads that are readily available to the civilian market. Take a look at Ukraine if you want to see how they can use just gasoline and homemade bombs and so on to defend themselves against a Russian attack. A much greater problem exists because of all the things that we depend upon for GPS. And cyber attacks on the from an unmanned aircraft system or on unmanned aircraft systems, and also ADS-B systems, represent a much bigger terrorist threat and a safety issue, both in the United States and Europe and in parts of India and Singapore and so on, than our FAA even understands. I'm a member of 2 of the committees, and we are looking at it a lot closer than what before. We need a risk metric, and I use the Ryan-Nichols equations because I had something to do with it. Risk equals threats times vulnerabilities times impact divided by countermeasures. To answer the question that was asked earlier, the purpose of vulnerabilities are everywhere. They are a weakness of the system. Take a look at Microsoft, you want to see. With the last presentation, a very good presentation, talked about all the various ways of attacking because there are vulnerabilities. Well, the vulnerabilities, though, are going to be there whether we have an attack or a threat or defense. Same thing with impact. The impact before 9/11 was 0. It cost nothing. After 9/11, the impact was absolutely huge. We had changes in organization. We had billions of dollars invested, sorry, and everything changed after that. But both of these, if you look at it in terms of time and taking a derivative with respect to time of the threat that is being applied or the countermeasure that is being used to defend, at time equals 0, both vulnerabilities impact are actually constants because they drop out essentially in our equation. So that allows us to do a comparison between an initial risk assessment, the IRA, and either a boosted defense or a boosted attack, either way, which then are able to be translated into normal, best, and worst case analysis qualitatively. Here's an example of the lethality legend I give my students. Many of my students think the cyber attacks and cyber approaches, even the APTs, are a high level risk in terms of homeland security and other risks that we apply. They're not. In fact, they rarely reach above low medium. And the reason for that is they may be millions of computers that are affected, and as talked about in the last very good presentation by Dr. Brown, they do affect things like Google and all of its servers, but nobody died. And in our game, when we're talking about defense systems, we're looking at how many people died and how many times the incident occurred. That's what counts. And sometimes that's a very different way of looking at it from 100 million computers. I can put my name on the web board. All right, so I want you to recognize something else. I talked about navigation for a second there. Everything depends upon GPS. Every car, every boat, every plane, every unmanned has some form of a navigation system on it, or it just doesn't go anywhere. On the ocean, or even in the Chesapeake Bay, for instance, a 1 degree off on a navigation error can be quite significant. So you need to have something that is useful. And currently the FAA, of course, has talked about ADS-B for localization. They generally work with ADS-B in, meaning signals coming into it, versus out, meaning I'm going to tell the other vessel or the other unmanned equipment or the other aircraft that this is what I have. There are cooperative systems, but in general, we're concerned with the inside of it. And they are fundamental to the terrorist operations because they can be used as a weapons platform by assassination, IED delivery, aircraft attack, drone swarms, which we'll look at in a minute, attack on vessels on open water, which I've been most concerned with since 2017. We have a martyrdom drone unit. And then we have a very sophisticated set of attacks, which is denial and spoofing and retraining, meaning the signals that are being sent can be spoofed or received can be spoofed, either side. And lastly, unmanned underwater vessels and submarines to rescue vehicles. Why would we concern ourselves with a small attack by an sUAS or cUAS versus a missile on an adversary or a big bomb? Well, I can go across the perimeters, and this is done all the time in our jails. We're always seeing something coming across the perimeter of the jail with either drugs or money or contraband of some kind. We can have an attack over national borders. We see that on the southern side quite a bit. Carry out multiple simultaneous attacks. We see that in Ukraine. Conduct an attack campaign, so on. Swarming attacks to overwhelm an air or sea defense. And some of the tests that we've seen do just that, and it's very scary. I want you to contemplate a terrorist spoofing attack on the GPS systems that take care of an entire area, let's say the Northeast, and how that might overwhelm our forces. Or we could do this in the South China Seas, which with Taiwan and Chinese implications there. So our first issue or our first concern would be, you hear about them, the RDD. What happens if one of these UAS drops a bomb, a nuclear bomb? Well, it's not a nuclear, it's a weapon of mass disruption in a sense. You have an incident, yes, but generally the amount of radiation cannot be detected by human senses, which is what scares people, but the effect is much less than if we were talking about a major nuclear, several kiloton type bomb. So what it is a conventional explosive that is blown up with radioactive material in it. It doesn't release enough radiation in general to kill people or cause even severe illness, which is what we look at all the time. But the fear and panic, if I put this over the Super Bowl, for instance, or the contamination of property, if I drop it in the middle of New York City's 42nd area, and the potential cleanups are substantial. The next thing I want to talk about is SCADA machines. SCADA machines are supervisory control and data acquisition systems, and they facilitate the management of everything. Every single device you have in your house has one of two connections, either a SCADA operation, meaning it's being controlled, the temperature system there, the water control. I used to tell my students that I could tell them how many times they flush their toilet just remotely by knowing just one piece of data, and that is the electrical meter outside. And I can then correlate that to the number of valve changes in the cold water distribution. It's quite an interesting calculation, which you have to see to believe, so to speak. But at any rate, UAS are just flying SCADA machines. And right now, the secondary problem is that IoT is being added. So not only do we have all the legacy issues of a SCADA system, which have a lot of issues, security, but now IoT, which has absolutely none for all practical purposes, is being given the access that the SCADA supervisory has. So somebody on the remote in Afghanistan or in North Korea can control your systems in your house. It was done by ADT. There are some inherent vulnerabilities. There's so many of them that the government has a wonderful laboratory out in Idaho that looks at the SCADA technologies in the government and has come up with 25, 30 wonderful recommendations. They are followed. I had a conversation with the Defense Reduction Agency, and they are in fact used in most of the facilities. That doesn't mean they're used in your house. Some of them is that inherently you have poor authentication. You have all kinds of interconnectivity. You have obviously wireless systems. You have weak access control on the fireworks. It basically is the first compromise an attacker will go for because it's too easy. It's a low-hanging fruit. And public information. We no longer have people come out and help you anymore fixing something like IBM did in the years ago. We have everything is on internet. Everywhere you go, everything is trying to go paperless and on internet. Well, that also means that all the information on the systems are available on the internet. That's exactly what was used, by the way, for Stuxnet and later Duku. I was involved in that project, and it was a fascinating kind of piece of work, very compartmentalized, but at the same time, the open vulnerabilities of the systems that we were looking at were in fact on the internet, and we had 7 zero-day visits. By the way, anybody who thinks Stuxnet was a virus needs to go back and start listening to Dr. Brown, because it was an advanced, beautiful cyber weapon that had multiple controls and multiple attack surfaces and multiple, it even had false flags in it that made you think you were looking at the French. Getting on to a little bit more, there's some other things, not just attacking software, so to speak, or the actuators or controllers on chemical plants, that kind of thing, but we can also attack these ASIC chips themselves, the application-specific integrated circuits. Who does that? North Korea and China. And in fact, many of our chips, which we used to have control of back in the 40s, 50s, and 60s, we do not have anymore. We own less than 25% of the market at this point. Most of it comes from Taiwan, one of the interesting places that is under threat. In fact, Taiwan makes somewhere in the order of 75% of the chips that are used all over the world. We can also corrupt the authentication of our ground station, not just the satellites, but the ground stations. Why, again, I'm going to go back for just a second and ask, what makes the sUAS such a threat? Well, first of all, the actions necessary to stop it. The targets are usually about 1 mile away. We're not looking at something 25 miles away trying to get feedback and feed-forward feedback kind of radar systems on it, so we know where it's coming and make our calculations how to get rid of it, or how to blow it up, or how to delay it, or send it on a different path. We're interested in a direct attack that has a small radar signature, and there are stealth methods that we write about that can make this thing even quieter. The reaction is, although it's a slow-moving target and it's very low, in many cases the radar identification thinks it's anything from a bird to just nothing. I mean, they just think it is noise, and that's a problem. Again, noise is an issue in urban areas. It's also an issue for detection on almost all of the research that is done for detection of either jamming or spoofing. Let's see. Let me keep going here. These are additional vulnerabilities, such things as gains and landing and cruising. Fuzzing, you can change the update rates, control acquisitions, SCADA buffer overflow. All of these were mentioned, and some of them mentioned in the previous two, so I don't want to go over it. Navigation in space, by the way, is a difficult problem. Not only do you have 3 dimensions here for a sense and avoid calculation, you actually have time, which makes it 4th, and 6 different ephemeris, because the satellite is moving relative to where it is in the location of all of the objects in space. Plus, you have to keep track of such things as space trash, which is another interesting thing in terms of getting a correct navigation signal. And because of the distance between the satellite and the Earth, if you will, the signal coming into Earth is very small. It's very low attenuation on it. I'm sorry, high attenuation and low power. Most of the research that's been done is on single source versus multiple source attacks, and countermeasures that have been developed for it are on single source. This is not what we're going to look at. The spoofing side is the most dangerous and the most effective, unfortunately, and it can be precursored by jamming. So GPS spoofing is the deliberate transmission of a forged GPS signal, resulting in receiver computing its location wrongly or failing to estimate any location at all. Spoofing threats range from simple to complex. We've done some interesting tests where we have removing an organ from one hospital to another. You have a 4-hour window, and we can spoof the system even in an urban area, which is difficult, and send that to another location or completely drop the UAS. The worst case system, the worst case analysis under Ryan Nichols is just basically complete failure of mission. The little bit better is reduction of the error. But either way, the heart goes the wrong place. So we have a thing called ECD, which is Eichelberger's collective detection method, which includes the fake signals in a minimum of 4 satellites, and it does not care that it's fake. It basically glums them all up and makes no a priori decisions whatsoever. Here's how we get into the 3 cyber attack and 2 analysis activities, if you will. We want to, if we're looking at AIS, an automatic identification system, we want to break that GPS receiver lock. Once we've locked onto the GPS tracking system, either at the satellite level or the ground, or in fact, in the minimum, you might have a hail or a mail type UAS, any of those 3 places, but generally it's at the satellite level coming down, or the receiver level. And the receiver is, by the way, picking up information at about 30 seconds. The standard receiver picks up about 30 seconds worth of data. We want to maintain the access after we've got it. We want to broadcast the fake GPS, then we want to collect and analyze data and report and go over directions for further hacking capability. A nice little signal generator we've been using is the 4100. So There are some automatic countermeasures that we've seen that are effective. There are a lot of them out there, but these are the three I've chose. One's is lit eyes, detect, track, and disrupt the operation by a pulse frequency jamming. It works very well. The Chinese have a laser, which is very expensive, and it has a very short range of only 1.2 miles and can only take stuff up to about 112 miles per hour. But it does shoot down these sUAS. You've seen other collection systems where they put a net over it, and there are other ones where the radar is able to overwhelm it at times. The one I like, and the one my teams have been working on, is sound. It turns out that large, harsh, intense acoustical noise, low noise, results in a reverberation on the MEMS gyroscope and degrades it, and the rotors spin at different speeds and malfunction. So if I can knock out one, I can take it down. If I can knock out two, I have knocked it out completely. If I knocked out one, I've at least put it onto another waypoint or into an emergency return. So sound is a cheap route to go. Currently, we're able to do LRAD operations for the Army and for the Navy, have about a mile capability and have a high power requirement, of course, but it's very effective. So going back again, before we can get into the arsenals against us, I want you again to recognize that ADS-SB, the automatic dependent system broadcasts that are used on aircraft and unmanned aircraft, are really a localization problem, and that they are a subset of anything bigger. So they are a subset of GNSS, they're subsets of GLONASS, they're a subset of all of them. It doesn't matter that it's a subset, because any solution I can get to the larger problem also solves the smaller one. And that's exactly what Dr. Manuel Eichelberger, he's a Swiss scientist out of ETC Zurich, who invented a detection, mitigation, and recovery of spoof GPS signals. I want to repeat that: detection, mitigation, and recovery of spoof signals. He didn't look at it just as the lion's share of, like everybody else is doing over the last 6 years, trying to detect a spoofing attack. He solves it. I honored him by giving it his name. I know him personally, and he's a very young and brilliant guy. I hope he does very, very well. But at any rate, his algorithm essentially says, I'm not going to look at the arrival time for each satellite. That's what most of them do. Secondly, I'm going to combine all the information I can find, and I'm going to decide at the end of the communication. Third, I'm going to take the false signals in as a market basket of signals, basically. So I've got, say, four satellites out there, 3 of them are bad and 1's good. I'm going to take them all in. Then I'm going to do selective collection, if you will, to eliminate by reduction of power, 60% on each round, and to synchronize the coding so that they're essentially all the same. You do this in cryptography, by the way, in the old classical, where if you were using Viggy, you would try to find the period, and the period is synchronizing the alphabets. Well, it's the same kind of thing. The ECD reduces the ECD is consistent in all 4 dimensions with all space and time. It is computationally quite expensive. That is our main pitfall in ECD. But, whoops, sorry, I hit the wrong thing there, guys. Pardon me. Close enough. So it is, ECD is a maximum likelihood snapshot receiver. Well, a snapshot receiver is a 1-second receiver. It's a very different kind of thing from the standard receiver, which takes about 30 seconds. It uses what's called CD, or collective detection. And collective detection has been modified specifically so that it can see multiple locations and treat every signal at the same route by reducing by power levels 60%. It defeats every known system we know of. It does not do well necessarily in urban areas, but it does extremely well in all the other classical FAA approaches. And it uses this, what's called signal interference cancellation. All right, the next signal, the next figure shows 4 satellites with received PRN sequences. And those spikes that you're going to see in just a minute indicate the codes at the beginning. And then he aligns them algorithmically, aligns them by shifting the correlation vectors so that by the true distances from the satellite. Then the ECD SIC algorithm applies to find the true signal, which in this case is 1. My apologies, people. Okay, here it is. I will try not to keep my hands on this. You can probably see up here at the top where the spikes are coming from different locations on each satellite. Only one of these is the good one. And then what has happened is we shift these by the actual distances from the satellite algorithmically. And once that goes, then he can selectively use the algorithm to select the right one. Got it. All right. I want to talk about Taiwan. And I want to talk about the South China Sea. Since 2017, I've been involved in open and classified work that is surrounding U.S. vessels and potential problems in the South China Seas. What I'm going to stay here is our research. The Navy does not officially agree with me, which is okay because I've talked to the right people there. But what you're looking at now are, in the yellow scenes here, are the vessels that were collided with by larger vessels, or they were, and we lost 20 sailors in the process of these collisions back in 2017. The black one is an intelligence operation. The green ones are US intelligence operations, and the red ones are Chinese operations. What you now see are the Spratly Islands here. And the Spratly Islands are all claimed by a whole bunch of people: Vietnam, China, Taiwan, all do this, the Philippines, and Malaysia. I don't think Singapore has it in. Brunei has another one. None of them compare to what China has on this game. Those red signals are the intelligence operations of China using unmanned aircraft systems, and I'll show you their workhorse in just a minute. And look how they interrelate. Now, this is just at one time, one period. It's actually quite a bit more. And it's all trying to determine the positions and protections that the U.S. Fleet has there in this particular case. All right, in 2017, the U.S. destroyers John McCain and Fitzgerald collided with the Alnic MC and ACX. I purported at that time that these were from UAS released from a Chinese base or from a fishing vessel, because it doesn't take very much to release a small UAS that in fact gave a GPS spoof. The Navy came out with a report that did not agree with that. They said it was training, and they said the captain was too young and so on. And a lot of people lost their jobs because of these. I'm more concerned with 20 dead sailors, and I've spent 7 years trying to find the truth and behind the noise, if you will, and also to honor those sailors. We also have suspicious of GPS positional spoofs on the Champlain and Antietam and the USS Louisiana. All of these are in the South China Seas, but we also have some data which is not open on Australia and some Chinese operations on Australia that would confirm this. The Navy has agreed to look into it. That's as far as I can go on that. The main workhorse of the Chinese in this case is the BKZ-005. It has a range of about 1,500 miles, and it can go up to 26,000 feet. That's the big one for the intelligence operations, but they have a lot of smaller ones out there. It is long endurance. It's not a VTOL, and it can be launched from a carrier, which it generally is, or from ground stations, and they have ground stations in the South China Seas. It has the capability of electrical, optical, infrared, synthetic aperture, signals, intelligence sensors, satellite communications, everything. It's very much like our Predator drone. And it was used by the PLA for China and modified with weapons payloads. Here we see the target for land, sea, air, and space for target characteristics, if you will, for Taiwan. Well, why am I concerned with Taiwan? Because Taiwan has a great deal of electrical manufacture, including our ASIC, not our ASICs and so on, chip manufacturer. And it is prepared to fight. Even though they lean Chinese in a sense, they're prepared to, like Ukraine. It's not going to be simple, but China doesn't have to send troops in. They can do a great deal of things first. And you'll notice there's kind of a line between the East China Sea and the South China Sea through the Taiwan Strait, which was brought up back in 1946, I think, 45 or 46. And it's just a line, an imaginary line, which was supposed to stop any incursions on Taiwan. It is part of the China Sea. It connects the East China Sea in the north and separates the province from Taiwan. There are some controlled islands by the People's Republic of China. The rivers that empty into the strait are there too. Here's another look at it. It's from a perspective of China, it is an open operation because they don't have very many naval access to the second and primary or secondary lines of defense. We have a substantial and significant influence from Guam. And from Japan to Guam, this is called the second China seas. You can see where the fleets are in blue. You can see the American naval bases in Korea and in Japan. The Philippines also is a primary part all the way down to Vietnam at this point of what's called the navigational choke points. What we're trying to do is prevent them from getting their submarines past the second second line, if you will, critical chain. Thank you. So the second chain includes the Marianas, the Palau Group, and other small islands. China would have open access to Hawaii, to Midway, to San Francisco. And right now, they are unable to put any naval bases there because of us. But they can go as far, if they take Taiwan, not only do they take the industries that are available there, but they are also able to get an open warm water, if you will, operational and tactical view to the second chain of our defense. From a geography standpoint, it's an increased threat to Japan. It's an increased threat to our 7th Fleet, and it endangers South Korea. Shifting for a moment to some of the other areas that they're planning in the attack on Taiwan. By the way, it will be a cyber first attack, and then they will take the islands around it. I want to check my time frame here. The Google and Facebook have paid for the construction of nearly most of the telecommunication links in that area. There are about 300 submarine cables that carry somewhere on the order of 90 to 99. I've seen 2 estimates on this. World data traffic. If they were cut, they would cause a huge problem in almost all of the North Pacific, South China Seas. Here's what one of these guys looks like. And I'm going to roll through these much quicker now. The China claims that it has 85% of the infamous 99 dash line. That was the one we were looking at before. This is a look at submarine cables all over the world. And they're about 99% goes through on these underwater. If they're cut, they cause an extreme threat to all the countries, Europe, Asia, and America, and the Five Eyes and so on. Here's the arsenal that China has against us, and then we'll stop after this. The BZK-005, the Sharp Sword, which is a VTOL made from Tribal, a German one. They have this clever little dove, which, by the way, looks like ours very much. It's a teeny little guy. Ours is very small. It's even smaller than this. Here is a swarm of over 1,000 UAVs. And think of the SCADA control systems that had to make this thing work. Just to up, down, and so on, the command thing. Just incredible. Here we have Ukraine operations. Drones are being used to drop the Molotov cocktails into Ukraine, over here to the port. And on the starboard side, we have a grenade that was improvised. One of the ones what they call the EIMs or LAMs, and our Switchblade 600 is exactly like, or where theirs is exactly like ours, called the LAMs. From an intelligence side, they can use what are called the CH-901s. They come out in groups of 9 to 12, depending on the launch system, or 1, and they're very portable. Here's an example of that happening on both mobile side and standard and a mobile carrier. I talked about the cables. The Chinese, the Indonesians, by the way, captured one of their UUVs. This is what it looks like. This has the capability of explosive. It also has the capability of adding on additional sections in the port side. This is a UUV. It's one of their larger ones, the HSU-001. Here's a comparison of these UUVs for the United States, Russia, China, South Korea. We currently have the biggest one, but not by much, and that's the Orca. The ones that the Chinese are currently looking at are the LDUUB, are the HSUs, HSU-001, which is about the same size as a Russian and United States component. They also developed a similar one. We have the Sea Hunter, which is unscrewed vessel. It's about 40 meters, something similar as the Chinese USV also. They call it, I don't have a name on that. That's interesting. Last slide is, look at this closely. This is an artificial island in the South China Seas. This is what you can see from satellite view. If you look down on the starboard and the stern there, on the starboard side, you'll see that there's construction underneath it. And underneath the port side is an entire base for UUVs. This is one of several that have been developed out of the Spratlys and would be used against the American fleet. It would also be used as a launch point against the Taiwanese island. That pretty much does it. And I thank you for listening. I hope I didn't overwhelm it too much there. We're done. Thank you again. Do I need to do something here?
Professor Randy, for great insight on US intelligence. Appreciate your insight. So, so how do you see, how as a country we should prepare against this counter?
I'm sorry, could you repeat that? I had an interruption there real quickly.
I'm looking at the series of questions, and most of the people are the common questions is how do US can prepare against this counterintelligence against certain countries. So what is your perspective on that?
Well, first of all, we have to realize who the real enemy is. Currently, we're spending a great deal of political capital on the wrong one. And we still think that we're in the Cold War. No, we're not. China has been on a plan, a strategic plan. They call it the New Silk Road Plan, or there are several versions of it, but ultimately they're spending money, they're spending capital, they're spending people, they're spending military, they're spending research time to knock us out on every front of the world markets, literally. And I think you're going to see that this is going to escalate. So how do we change this? We go back to our strengths. Right now, instead of giving away energy, we build our own. Instead of giving away information so freely, we bring it in hand. We spend some research through the advanced research capabilities of both educational institutions and DARPA and so on protecting what is our, and this, by the way, this our could be for any country. It's not just US, I'm talking about India and Israel or England and so on. I mean, everybody has to take the same view because China's not just looking at us, they're looking at everywhere. And they're pretty clever about it. So we need to understand who the enemy is. And once you understand who the enemy is, then you can start preparing correctly for it and put our priorities in the country different.
Great. So I know that you talked about ECD approach. How do you see this ECD approach against the spoofing, next generation spoofing technologies? Do you think, would you shed some light on that scalability of this approach on different applications?
Yeah, I'm really a big fan of, you're going to find I'm a big fan of ECD. And we literally have it in the Assure 44 group right now. So we're spending some money to do the testing. It's not in flight testing yet. And it is, it's in more simulation mode all over the country. But the good news is that the simulations are showing what it means. So we need to go the next level. I'm hoping that Assure or FAA or NIST, one of the three of those guys, will pony up some money to let us go to a flight testing. And at that point, you'd have a real operational defense against spoofing and jamming. But on paper, like anything else, it's pretty good.
Cool. Yeah, I think those are the questions for now for this speaker. Thank you so much for your time today, and it's a distinct honor. We will mail you a nice flag to your mailing address. If you could please send us the correct mailing address, we'll get you this. Thank you so much for your time today.
Would you be kind enough to give out my email to anybody that wants the copies of the free ebooks, the textbooks that we use for our aerospace and cyber operations?
Sure, we will be happy to send out your email to the list server, so we'll register. Sure, we could if you can send me the link of whatever that you want to share, so we can send out a mass email.
They're in my email, which you probably have multiple copies of right now. Thank you, and thank you, by the way, for the opportunity.
Yeah, thank you, Dr. Randy. I appreciate your time.